All microphones mute.
This meeting is being recorded.
Good morning, everybody. Today is 27th episode of Tech Forum's Sunday Tech Talk. And today's topic is Mechatronics by Mr. Sudhir Karkare. Before I introduce Mr. Sudhir Karkare, please join me congratulating our EC member, Mr. Gautam More. Gautam has bagged Entrepreneurs International Award for excellence in entrepreneurship, research and innovation. This is a very prestigious award from Entrepreneurs International. It announced today morning. Yesterday, there was a display of Gautam's product at MIT Incubation Center, and I witnessed his product. It's a really professional and in line with international product. The ceremony of awarding this award is at Natasamrat Nehru Phule Natyagraha, lane number 3, Samrajya Housing Society, Vinayak Nagar, Pimpri Gurao, that is Pimpri Chinchwad, Maharashtra, Pune 61. It will be in between 6:30 to 8:30 p.m. I will put formal invitation for all. Please do join and grace the occasion. We'll go back to our program. Today's topic is mechatronics. Speaker, our old member, Mr. Sudhir Karkare. Mr. Sudhir Karkare is a B Mechanical from College of Engineering, Pune, 1976 batch. And I think he has born with a lot of innovations and innovative ideas, because if you see his biography, you can easily make out his achievements in various areas. He started his career with telco those days and went for specialization in automobile and industrial instrumentation cluster. Designs of various paramilitary use was the main focus. Also started a company named Mechatronics to manufacture police equipments in India. For last 30 years, he is handling R&D projects for various industries and defense sector. Railway is one of his specialty. As a special activity, got involved in generating Indian vendors for Sukhoi 30 aircraft for 40% import saving. Started manufacturing special purpose machinery or system to help and solve the problems in various industries like automobile, aeronautics, pharma, food, textile, plastic, etc. Presently, Mr. Sudhir Karkare is running a machinery manufacturing plant in Pune, with a workforce of about 20 people and handling mechatronic activities. Some of the major industry clients are Hindustan Unilever, Cummins US, Helical Auto UK, Bosch India, etc. Spaco Corporate is also one of his clients. More than 250 machines of different categories are supplied to various clients. Lot of R&D support systems are designed and supplied in academic field for National Chemical Laboratory, National Physical Laboratory, CSIR labs, and many educational institutes like IIT Kanpur, Pune University, ARAI, Dharwad University, etc. Since water has become a challenging subject, last few years focusing on rehabilitation of dam instrumentation. Dams have a geographical instrumentation to monitor the health of such a huge civil structure. For this, designing and manufacturing electromechanical sensors and system data logger, data transmission, etc. With latest manufacturing technologies are being done for last 14 years. He has also worked for CWPRS. His biodata is long. One can go through, which I have attached to his CV. You can see also a lot of photographs of his creations and various exhibitions where he has participated. Without spending much time, I will request Mr. Sridhar Karkare to start his presentation on mechatronics. And mechatronics is a vast subject which started sometime in 1970 and which has grown multifold today. So over to Mr. Sridhar Karkare.
Thank you, sir. Hello, can you hear me?
Yeah, go ahead.
Okay. Uh, One second, I'll just come up with. Sorry, there is some screen coming over here. I don't want to. 1 second, sorry. Tushar?
Sir, we are able to see your shared screen.
Yeah, but this meeting is being recorded. That message has come.
You can start talking.
Okay. Yeah, we'll
Just
go
say
ahead.
got it.
Got it. Okay.
Just click on.
Okay.
Just
Okay.
click on got it.
Got it. No problem. Okay.
No, just click on got it.
Did it.
Click.
Okay.
No, it is
Good morning, everybody.
visible.
Good morning, everybody.
Good morning.
The subject mechatronics. Last 20 years, 10 to 20 years, this word has come famous. Earlier, people used to do a lot many things without electronics because electronics was not that popular. After the nets and Google and everything came into picture, we engineers really got some boom and we developed lot many things using some sensors which were not there earlier. Now, mechatronics is particular line where mechanisms along with electronics, along with hydraulics, pneumatics, rest of the things, including chemistry, can take your product to the final level of achievements. Since I was involved in lot many projects where all PhD people or R&D people were involved, I could come across their problem because all the time people used to buy equipment from abroad. We were always very weak in R&D support. And I was always surprised that why people should buy equipment from somewhere else like US, Germany and all that. Are you getting me?
Yes, sir.
Yes,
Certainly.
very much.
So in that context, since I had some lot of experience with working on some imported equipment for repairs for Japanese, Swedish, German people and all that thing, I realized that we also can make something useful for our own purpose. What used to happen was people used to buy some equipment by seeing catalogs. There was no other choice. And when the equipment comes to you, you start using and then you know that something is required. This is not there, that is not there. And I used to upgrade those machines or modify. So that gave me a lot of experience on working on imported machines. And then I realized that they only know some more pages of information than we people. And they have very good access to get something like sensors or power supplies or electronic components or something, which normally we don't get so easily in India. But last 10 years, the picture has been changed. Now this whole system has come to a limelight and a lot many people are interested in doing that. People have developed so many new systems along with new sensors of their own. And all those things were in picture and people didn't know where to use them unless some occasion comes to them. No, I was working on Sukhoi 30 projects in Nasik. And Nasik, there is one agency called as MERI, that is Maharashtra Irrigation Engineers Institute over there. And one of the engineers told me that he is a member of dam safety. Now, Maharashtra has got more than 5,000 dams, out of which Koyana Dam is the VVIP dam. Rest of the dams are also there. But you can imagine so many dams are there. And he said that we are always under tension that what happens to their safety. Because the dam, we have some incidences in Maharashtra of dam breakages and floods and whatnot, disasters. So he said that if you are working on aeronautical engineering and electronics involved in that and sensing something above the sky level, why not do something for us on the ground level? So I liked his idea. He said that I am a retired person, but I will spend my own money on this. And you believe me, he put his all provident funds to me. And he said, you do whatever R&D you want. So I was little shaken by his way of thinking. And I said, okay, whatever you want, I will do. Forget about money part, but we will do something which is required by our country. And then I went into this. And in the whole process, I got a lot of chances to work on Koyna Dam, then Bhatsa Dam in Mumbai, then so many dams in Karnataka, Orissa and other things. And I could realize that this particular area is neglected for various levels because all governments are dealing these dam officers and they're all, their tenure of manufacturing, construction to final level maintenance and whatnot, everything. While doing so, CWPRS, which is a Pune-based central organization, which is taking care of dam safety and the further next 25 years planning for water. Being near to my present workshop, not many associated people came and they saw my work and they said that we want to learn from you because you have done something which we people have not done for so many reasons. And being a government organization, the process is little lengthy, whereas we private people can do it faster. So they gave me a lot of free hand. And one of that process, I got one opportunity to work on dam, which is called as Mulla Periyar Dam. Now, that is the story I would like to take further today. And we come down. Where is it? Next. So this laptop is different.
Place the space bar.
Yeah, I've already done that. 1 second.
Try arrow key.
Next. 1 second. Can you give me 1 second, please?
Yes, sir. Please.
I'll do 1 second. Don't know what happened to this. Next. I don't know how to go down now. This first slide was introduced. Okay, fine. Okay. Sorry, friends, I'm little not aware of these situations. Okay. Can you hear me now?
Yes, please.
So I'm back to the subject. This Mulla Periyar Dam project experience. It's a very unique experience. And I have mentioned in my mechatronics introductory words that we engineers, we have limited experience in normal case. Very few people, they get some odd situations to work in, and then their performance and their contribution to the system, like government, maybe different associations, that becomes a very vital thing. This Mulla Periyar Dam, as the slide shows, it is in Kerala on the river Periyar. Mulla Periyar is the word which means like big river. So this is a big, huge catchment area, and about 120 years back, this dam was built over there. And Kerala and Tamil Nadu has got some tussle on that. I have mentioned over there. The dam is in Kerala and the management is of Tamil Nadu. Now the dam is producing 150 megawatt power. Tamil Nadu uses it. Dam is of Kerala, Tamil Nadu uses it. Water is of Kerala, Tamil Nadu controls it. Now this whole thing got a little bit political problem over there, saying that already that 120 years old dam, that falls into the zone which is a earthquake zone, and we are shaken. If something goes wrong, the whole Kerala, Idukki district and other thing will come into the floods. So they were shaky, saying that this dam is to be demolished. So Kerala said that dam is 120 years old and unsafe. Then if new dam is constructed, ownership will go to Kerala, which Tamil Nadu could not agree. There were studies on IIT Delhi and Roorkee. Roorkee, you know, the basic center of India where earthquake data is collected, and they have done a lot of R&D on earthquake throughout India and Himalayan terrain, including Koina. So Koina, let me tell you one small thing of Koina. Koina is a place which is selected as a world's laboratory for earthquake. There are 6-7 different nations which are allowed by our country to carry out their earthquake trials, earthquake data trials, and they have given special spaces for their labs. A very, very, very rare situation of geology, which is at Koina, and that is being studied all the time. We worked over there, so we could understand almost every day about 1,000 mini or micro tremors are going on. That is the earthquake intensity over there. So it's a very good model for studying earthquake matters. It is very difficult to produce earthquake in any lab, you know that. So this Koina is a very live sort of model, and so naturally so many scientists, they are attracted to it. Now Tamil Nadu approached Supreme Court saying that this dam is safe, nothing wrong, because they have to maintain their own interest. In 2010, the Supreme Court, they formed an empowered committee. This empowered committee is normally formed by those people who are from the secretary level, scientist level, all sorts of top people, and who are working towards the national safety and security. They have nothing to do with politics. They have planned for another 30, 40, 50 years, and they are well connected world over, because such subjects are there which doesn't have any boundary of politics or other, enmity or something. Because water, to your knowledge, I don't know many people know it now or not, water is now an international property. Believe me, water is an international property. No one can say that this is my water. This is what is World Forum has already decided on that. That is why international monetary funds and world funds, they help to maintain the dams, which comes under a process which is called a DRIP. That is dam rehabilitation and irrigation process. A lot of more than 60,000 crores are available for India on selected dams, because water can be picked up from any country and given to any country by default without asking any political permissions, anything, because this is a commodity which should be used by everyone. Everyone has got right on that. So we know now that this particular Kerala and Tamil Nadu being in this particular fix, that whether the dam should be there or not, court came into between, and they said that some experts' opinion should be there, because court will say that we have to go with some reporting. Now 120 years have already gone. That means that time it was 110 years almost. Which report is available? So the only answer was technically perfect opinion supported by engineering data. Now this is based on the record of various instruments which are normally installed in dams, and you get the information for over a period of 10 years, 20 years, 30 years, 40 years. Problem here was different. The dam was built in 1896. It's not even construction of concrete. It is not even totally mason. It is a earthen dam. Now I'll come to that point because it's a very important and interesting issue, that why that dam is like this. And since the dam was there for last 120 years, there was people were saying that in the last 100 years nothing has happened. So another 100 years and nothing will happen. But there is no technical confirmation or any engineering support saying that, okay, this is safe, go ahead. So court was in picture. Now some authority in Delhi told that, okay, this is a third-party decision required because we don't want any government agency, because there is a political pressure. So CWPRS was a nodal agency and they were asked to do that, but CWPRS was also a government agency. They found that someone else has to do, and luckily we were known to a certain extent because we carried out a lot of experiments in the Koyna Dam, and we were asked whether can we do something over there. Now let me tell you, we are too small to handle such projects. Let me be very transparent to you. We were doing some experiment because we have that kida, what we call as, that let us do, let us try this thing. And Koyna was near to Pune, 120 miles, kilometers. And they could give me that opportunity that you carry out your experiments here, do whatever you want and collect data, etc. So that was the main thing where I took the advantage, and me and my people, we worked on that dam particularly for so many years, minimum 10 years, trying different sensors, mechanisms, and whatnot. Let me tell you here one thing. Koyna Dam is so nicely maintained. Like unlike any other government agency, the government agency which is looking after that dam is so methodical. They have got last 40, 50, 100 years of record on the write-up as well as on their computer now. They have excellently maintained their machinery. Everything is kept very in proper condition. And secondly, people know what they are doing. They have not transferred people for 25 years. Believe me, government people who gets transferred in 3 years, the people who are connected to instrumentation of dam, Koyna Dam, they are not transferred for 20 years, 30 years. For the same reason that they know the dam very well, they should not be disturbed because it's a very, very critical position where the Koyna Dam is there and no one should take any chance with it. So that kind of thing, if it is done, in case of Mulla Periyar Dam, there was no record, there are no sensors, nothing. How is to take care of this particular problem? Who will say what is to be done? The subject came to us. I'm showing you a photograph over here. It's a nice, beautiful dam between two hillocks. And what you see today is a comparatively new construction. And further 800 meters it goes back. And down the line, there is a 14 kilometers water storage area which goes into the wild sanctuary. And from here, you know, Periyar is a Mulla Periyar, or that Periyar is a tourist place, very well known tourist place near Munnar in Kerala. And these people are always getting benefits from the scenery over there and this water passage over there, because a lot of things are done over there with the help of government to achieve, that tourist business into a better shape. I'll just show you next clip. This is the scenario over there. It's a wildlife sanctuary. You have got tiger, you have got elephant, you have got bear, you have got other animals which are normal and which you can see over here with a bison and all that thing. You have to go by a ferry for about 10, 15 kilometers inside. Then you reach a particular place where the jungle is available. Till that, this is all water which is of the dam. So it's a huge water storage and at a very high level because it's a hill station. So you can imagine the advantage of tidal power. And that is why Tamil Nadu is producing 100 megawatt. They don't want to get away from this. And now this subject came into picture where how to take care of it. Supreme Court, since they were in picture, they were pressurizing all these people that do something, we have less time. So we started looking into it because I got a very good chance. I thought, why not to do it? Let's do it. So my people and me, we took a very big daring decisions. And here, as I mentioned, we jotted down what are the challenges for us. So one was the engineering challenge. I had to do something engineering which is accepted by the engineering departments of government. Second was the political pressure. Now that should not affect me or my people because this is something which we never come across. Political pressure is there with the people who are in government business with tender and this and that. But especially for such cases where some diagnostic analysis is required, people will not take chances. They call foreigners. CWPRS didn't call foreigners. That was the greatness for them. At the same time, Indian government or rather Indian court, they were also insisting that let it be done by our own people. This is our own problem. Foreigners will come in and they can guide you any way you want. May not be in the interest of our country. It can be interest in our business. So that was a big thing which is untold, unwritten. But this is what we understood. And we said this is our test rather situation. Let's do something. Now we have to restore the originality also. We suddenly cannot say that change this, change that, because it's a civil structure. You can't touch it so easily. Upgrading to latest technology. Now, whatever is there, now the time is changed. We are 120 years ahead of the construction time. So something new can be adopted, including lasers, this and that. And why not to take satellite help from Google and whatnot? Everything which is latest technology available today. Now making it more useful, more friendly, user friendly. What is happening is we worked on so many dams in last 14, 15 years in different states in India. It is a lethargy of people because they don't want to touch that equipment. It is really actually difficult to handle. They don't know how to, like, right now I'm suffering because of this laptop is new. I don't know which key is where. So like that, to the people who are on the front, they don't know how to take the reading, where to write it down, what is the meaning of that reading, how to keep that record, how to put it to government, all those things. So it should be very user friendly. So right now we are using this word user friendly because we are tuned to that. Otherwise, this word was not there about 20 years back. Establishing capability. While doing so, there were so many people who used to monitor us, who should monitor us rather. And we should not say something which is hanky-panky or untechnical, so that we ourselves will be questioned by the agency that who told you to handle this thing, you don't know anything. So capability handling or capability establishing was a big challenge for us. And the last one is the language problem. See, we were going to be over there for some period, talking to the engineers over there or whoever is there. Unfortunately, those people don't speak Hindi. English is okay, but the language problem was definitely there, which we jotted down. This is the problem which are going to be, we have to face it. Now, what is the solution? Trying to understand the problem, that's the first. Scrap all existing, whatever is there, because unless something like this is done, it is like, taking a patient to a hospital from first dispensary. The first dispensary, first doctor has given something, patient is not okay. So the next doctor says that forget what he has done, let me check newly. So like that, scrap all the existing system and try to install new where we believe that it is okay. Because that was the experience what we had. Design new system, once it is there that we know what is required, design a new total system with local surface, local sources. Local sources is very important because this is the area where it's very difficult to reach by road. Today itself, even in today's date, it's very difficult to reach. Roads are so small and like landslide, this and that, other problems are there. And mind well, it is a wildlife sanctuary. So it's very tough to work over there with the limited resources. Decide whether to handle this situation or quit. Why I'm writing this here? Because after understanding the problem, you may feel कि this is ये मेरे बस का काम नहीं है, ये नहीं हो सकता हमारे हाथ से. Now this should not happen to any engineer. Let me plainly tell every engineer who is listening to this. See, we have got so many resources around us. We never tap them. The basic engineering is understanding the problem. You may not solve it, but understand it. You can ask for somebody to solve it, but understanding the problem, highlighting the problem, or rather the diagnostic analysis is the real engineering. That fellow need not be an engineer. He can be anybody. But if he can have analysis and he says, sir, this is happening after this, that happens a very good hint to us, and that is where the engineering starts. So I said that once the language problem is gone and other things are gone, new system is developed, then we will have no problems. We will be in a position to decide something. So we stopped thinking of quitting it. We took the challenge. Now, another 10 years, this time will be observed because it's not a 1 year job. Believe me, suppose you do something today on the dam, at least 2 years, that means 2 monsoons are checked because the dam gets filled to the highest level, one monsoon. It may not happen that year the monsoon is enough, water is enough, so it may not reach to the highest level. And then it is depleted in the whole area, like by March or February, March end, water is gone. So the whole cycle is to be repeated. That should be checked on the instrumentation, that what happened to the dam throughout the 7-8 months. And that gives you the indication whether this dam is happening. I mean, the dam is showing the results which are irradical or okay within the range or not. That is what is being done by instrumentation. Then suppose everything is done, I am convinced that my machine is okay and everything is there. Whether I can convince the higher authority because they are going to sign my final report. They're saying that this is okay or not. So it was a big thing, but we took that challenge. And the last was commercial matter. New dam construction cost about 2,000 crores, plus the time of about 12 years. Now, how to charge this? It was a big thing, so let it remain as question. With the knowledge gathered from various dams, as I mentioned over there, following fundamental physics and principles of electrical engineering, we decided to find out the health of embedded sensors. Now, what is embedded sensor? When the dam is being constructed, it goes for 10, 12 years. So layer-wise, some instruments are introduced inside, which are embedded. They are actually inside the concrete, and those cables, the connections are given by some special cables, which run in kilometers. They are laid down, and over and above new construction comes in. The road roller goes, the excavator goes, the cement machinery goes, the people go. You can see that 250 meter is the base of the dam and height is about 34 meters. So much of material comes on that cable. So it happens that if the supervision is not proper, the sensors which are already embedded in the initial stage, maybe at say river level, the cables, by the time they are being used, they are broken, they are stolen, they are gone. So it's a very tough thing that the engineers who are going to monitor this dam, the instrumentation, if it is not live, nothing can be done later on. You can't reach that mass of concrete because you can only show that point on the drawing. You have no access. So this is a very typical thing. And in such cases, a lot of R&D has happened world over because this is not the only problem of India. Everywhere in the world it happens. But that was our subject, and we said that okay, rehabilitation dam can be done something else. We can drill new holes, we can put new type of sensors, we can work on the surfaces, whatnot. So many other things were done. But instead of all those things being used over here, since it was a very old earthen dam, we said that okay, let us try with basic physics, electrical and geology and irrigation. What is being used is there for last 120 years, so believe in that. So we worked on that, and uh, more than 180 sensors were introduced by the new government, I mean the other government, in 1990. That was a time where this tussle, rather with this subject came in, that who is to own the dam. So somebody said that, of course, engineering division, let us introduce some sensors somewhere and at least get some information so that we know that dam is okay or not okay. See, it's a possible engineering. It's like, every time I need not go for ECG. I can check it with some stethoscope also. I can do something with BP also. So if ECG is not possible, at least have a BP machine at home. So like that, they decided the 180 sensors newly introduced after 100 years. Let us start collecting data. If there is something erratic, at least we will know that dam is safe or unsafe or something else is required. So now we have to understand the limitations of the engineering, and still we have to say that something is to be done. Now, if you see this photograph, you can see on the right side corner, the cables which are laid down, they are totally submerged into the calcination. This is a calcium carbonate coming out of cement, or that is coming out of earthen mass or from the water itself. There's a lot of seepage in the dam. So this keeps on happening, and it is like a hard water. So you can see that if this is happening, the board below that photograph shows what is the condition of the electrical contacts. That those are all rotten. You can't take any reading. And left side, both the photographs, we did something for the trials, and we have no option because we cannot go into the 100-meter or 200-meter or 1 kilometer depth and see from that where that wire is coming, what is happening to it. Instead, take a new chance. Wherever you find that something is okay, only test those particular parameters. If they fall in your machinery, what you have newly built, if they show some life, adopt it. Now here I have mentioned that basic problems of cable connections and failed electronics is seen over there. But believe me, my last 20 or 30 years experience as mechanical engineer, electronics mainly fail because of poor mechanical work. This is what is my understanding. And that poor mechanical is like fixing PCB with lot of tensions, improper screws, improper mechanical assembly for holding the devices. Heat sinks are having their weight on the component. They are dangling. So many other things. The gravity is not concerned. Lot many things are there. So I always say that electronics is good, but mechanically they fail. And there where we try to do a lot of things over there. Now, as I said, mentioned over there, based on some old reports of the management over there, using oscilloscope, frequency generator, our own machines, etc., 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 we made something over there. And our experience of Koyna Dam was very useful because there we had got that total open hand, and all those experiments came to our use, and we tried to find out that if something is live, let us go and do it. So actually, after seeing all the earlier work, we have to undo that whole work because that was not useful. So we did something new and we got some results. So for 2 days, we kept the system on just to see that whatever we have done has any meaning or not, because some erratic results can crop in. So 2 days we kept mum, nothing there, and we just kept on watching whether our, and lot of thinking and paperwork we did in those 2 days. Then when we started thinking on this line, we said, why not to make another new list system, all new together, and work on the paperwork, etc. So we used that time. We got the readings, but we don't know what is the meaning of that. Now, normally when sensors are put into the dam, they either give you stress level, strain level, temperatures inside, something else. If there is a movement over there, believe me, a dam is a flexible structure. A dam like Koyna, which is having 30-40 meter height, it's a flexible structure. When the dam is full and when the dam is less, down, it is depleted, the dam moves towards the river side, that means the downstream, about 4 to 5 centimeters minimum every year, and that comes back. That means the hydal pressure pushes the wall of the dam when the dam is full. Now, if that is happening to a mass, a huge mass, and it is coming back, that means something is required to be monitored mechanically. Now, those mechanical sensors are inside, which are based on variable frequency type of thing, or strain gauges, or so many other types, load cells, etc., which people used to adopt over there. Now, what information I could collect in last so many years, that after 1823, Germans and US people, they started using typical type of sensors in their bridge construction, road construction, and later on in the dam construction. Those were the pioneer in generating this kind of sensors for the civil work. And later on, they came to us in India during Jawaharlal Nehru's period through Japan. Japan, they gave us a lot of help as an international help to make this thing. And CWPRS Pune has got a lot of hand which is given by Japanese people with the connection of Pandit Nehru with them. And so many equipment which was Japanese was introduced in our earlier dams. Now those companies are also not in existence in Japan, but still we have got those instruments with us. Now, as I said over here, we got some readings and some data was also available with us. This is the way new system was later on done. You have seen the difference what earlier was there and now what is being done by us. This is the advantage of going into latest technologies and latest material and some more acquaintance, because now people know how to handle computer, how to handle PCBs, how to handle power supplies, etc., etc. So this is what was done over there, and we provided the data logger, which we went on doing something in Pune and shifted it over there as and when required. Now, luckily, some relations were established, and using the principles of geological engineering, we were told that some readings are useful. Now, this is something where you can always get a feel, that your patient is coming out of coma. We don't know that what reading is for what, but the dam authorities who understood this, they are sitting in either in Bangalore or in Madurai or somewhere else, and they're studying and telling that yes, these readings have some importance and they are relevant, because about a year's period they've monitored it. We waited further because they say one more monsoon we have to wait. So meanwhile, they appointed an engineer to take readings every day because that was our requirement. Monitoring from Pune was not possible and language was another barrier. We face problems like UPS and all other things because, as I showed in the photographs, the whole jungle is, inside. The dam doesn't have any electrical power. Even their own power they cannot use as a policy. They have their own systems with small generators, and for our system we use UPS. Due to Supreme Court orders, all attention was given because it was definitely a very important thing for them. Now we were eager to know what is happening because one monsoon we were waiting for that. And after about 6 months, the Supreme Court was told by import committee that the dam is safe. This was the winning stroke in our project. What we did came to a limelight, came to the level of Supreme Court where they could believe it, and they have put a remark that okay, nothing is wrong with dam, sufficient data is available, and we can say that dam need not be demolished. Now you can imagine today, right now when I am speaking this, I am going through that whole cycle. It was such a, like it's not only a winning cricket match, like it's a big dimensional win. And again, I'm saying it's not entirely on my input or something. So many people all the time who were with me throughout the projects, they have helped me out. And Koina, of course, they were highly useful, or their CWPRs. And I always say that this is the strength of engineering. See, this was totally unbiased experience. Nobody tried it. 100 years, nobody had touched it. We did something. We don't know the subject. We went into it by analytical method, did something. We got something which was accepted by the technical people who were the authorities. What else is required? So a dam of 1896, the dream project of Colonel Peniquick. I'm coming to this slide again because it's very important to know about this person. Colonel Peniquick was the civil engineer of British era, John Peniquick, who built that built that dam. And this dam was saved from demolishing. And more of that, the national property that got a new life. So very few chances we type of people get into the profession to deliver something in interest of the nation. Mind well, this is something when we say, or rather when I remember on the convocation day from the COAP, College of Engineering, there is one line which comes to your, they talk to you that if nation calls you, you should be available. That is your first task. One should remember that. I got a chance. I did it. Now, this photograph and other things what you have seen, let us understand one thing. Dam is situated in the place which is a jungle-like thing. Threat of wildlife is there. What we achieved, that was not the real problem. The further problem is here. So let me continue on that. It's very interesting. Our team of 4 people was escorted by 4 forest guards, who allowed to work between 11 to 4. Because before 11, you can't reach to that place because you can see the pugmas of tiger, elephant, everything. By 10:30, they go into hideouts. And after 4 p.m., the sun is going down. You should not dare because there is so much cold. You have to come back. You have to travel about 14 kilometers by ferry. So you have to wind up earlier. And those guards are there. They are on the duty. They have security measures. So they take you out. So we face the other problem. See, this conflict was in between 2 political parties. Just see, we are engineers. We never think all these things. But see what happened. This was a game of finance and power. As today also we know, we can imagine. We got the threats from one group saying that you should say that this dam is unsafe. And there was another group saying that dam is safe. Tell us. Tell government that dam is safe. Now they only knew that we have come here to find out whether dam is safe or unsafe. They didn't know who we are. They didn't know that what we are doing and all other things. So all the time we were under tension. Though the police protection was given, but the people used to gather around 30, 20, 40 people who were Adivasis also coming from the jungles. And we could realize from their language and body language that they are not happy with us. We are doing something and they want something else from us. But while coming back, we talked to our officers, police people, and said, our role is like this. Please convince them, talk to them in their language, tell them that they should not trouble us. We are not going to do anything wrong for them. It is for everyone. So luckily, we don't know, but our sincere and non-political, and pure engineering efforts, people got cooled and they could make, they made us work over there, and finally we completed the job. Now, when I'm saying that this dam of 1896 is the DIM project of John Pennyquick, you can see the bust over here. And on left side, you can see the Colonel John Pennyquick. There is a write-up. The quote is there. I shall pass through this world but once. If therefore there be any kindness I can show, or any good thing I can do, let me do it now. Let me not defer it, nor neglect it, nor I shall not pass this way again. So let me tell you something over here. This John Pennyquick, he was a colonel, engineer, civil engineer colonel. He was looking after irrigation. That time in the British era, it was not Kerala and Tamil Nadu, it was the Travancore Cochin province. So it was all coming under the Victoria, Queen Victoria. And all these people were there who were working as a government officers. And he was taking care of the Kerala side and that kind of area. He came across so many temples and sadhus and other people, and he felt in love with Indian culture. He started living and understanding the Adivasis. Now, if you see the Periyar is very difficult to reach even today. Imagine 100 years back, 120 years back, there were no roads. It's all full of jungles. How could he find out this place, that it is a place where water dam can be made, which will take care of so many thousands and millions of liters, which can help the Indians? I am saying that he thought of Indians. So he took care of this civil work and put the project to his government. Government sanctioned him something. He started working on that, and he tried to get the help from the Adivasis who were local over there, because transport media was not available. No tractors, nothing, no trucks, nothing. So he used masonry work over there with the help of the typical soil which is available there, along with some additives which he knew. And he started building that particular wall so that he can stop that water going to other side and small dam can be built. So he tried 4 to 5 years, and every time because of the monsoon, it used to wash it off. So twice, thrice he made the effort and he could not build anything. Queen Victoria told her that government finance can be utilized for this. You are spoiling everything. You are wasting your efforts and money. Stop doing that madness. So he said, no, sir, no, madam, this should be done. It's going to be a very big project. And let us do it because we have to do something to Indians. Because he got converted to that level of thinking that these people, they need some sort of support. Let me do it if I am here, whatever best way I can. So he tried to build up again one more time and again failed. So Victoria Queen, he shifted him from the job. He was thrown out. So this colonel who went to the Adivasis over there, and he said that now I'm not in government. I'm going back to my nation, going to my old native place, and let me see if I can help you out. But I am sorry, I could not finish this good project in spite of your efforts on this. Believe me, he went to his city, native place in England, where his father was an advocate. He took a big meeting in the church over there and explained his plan. They sold their own property. They collected money from the native place over there. He came to India with 43 lakhs of rupees that time. And he constructed this dam and completed. In 1896, for last 4 years, 1892 to 96, with the help of Adivasis there, with his own funds, he constructed that dam, and the dam was over, completed. He was happy, and he said that whatever I was supposed to do over here, I have done it. And that is why his bust is here with the writing over there on the other side of that bust, that shall I pass through this world once more? I can't. So whatever best possible, I will do it here. Now, why I am telling this? He was an engineer. He was paid. He was an officer. He was colonel. He could have done anything, whatever he wants, because that time, the Britishers were king. Why he did so? And if he did so, he handed it over to the people of India, like Kerala and Tamil Nadu. Understanding this thing, can we think that somebody who has done like this should be demolished for only political reason or for only finance? Now we know what has happened in irrigation departments in Maharashtra and elsewhere. We know today's conditions of our dam and all the economics behind it. Imagine this particular thing. And then when I understood this history, that day I said, I need not charge anything to these people. That is why I said the economics, I put a question mark. I said, this is an opportunity to us because I am not going to come here again. But let us do it. And if it is working, let it be a national property saving, which I am supposed to do as an engineer. And we did it. And now everything is put to you. It is not known. This story is not known to many people. Only very few people know, because as such, being a court matter and other things, very few people know about it. Now, thing is, the court matter is over, about 12 to 15 years now gone. Nothing is wrong. Dam is standing very stout over there, and people are happy. And it is now protected further because now engineering has been done properly. So they have more confidence and they are in touch with us. We keep on visiting twice or thrice, I mean 3 times, once in a 3 time over there, talk to some people who are not transferred. But we are happy that we could do something to save this. That is why all the time I'm saying that we have saved a dream project of Colonel Peniquick. Now in last 20 years, 12 years rather, we have developed so many instruments for dam, like digital plumb line with earthquake data capturing, laser sensors, ultrasonic joint crack meters, uplift pressure lines. These uplift pressure lines, I will tell something who are not knowing about this subject. You can, let me take 1 or 2 minutes extra because this is a very important thing. The dam is across across a river. That river and the place and the foundation, everything is selected by proper engineering. What happens is when you collect so much of water inside the river, which is running across as a backwater, maybe 10 kilometers, 15 kilometers, 20 kilometers, that hydral pressure generates so much of seepage, and that water comes to the down level, below the ground level, and starts to find out way below the dam. So you can imagine the dam can get lifted because of that water. That is why that pressure is called as uplift pressure. So you can, it's a huge pressure. Actually, the dam can get lifted, and that is where actually the dam breakage starts. So that is why uplift pressures and other things need to be monitored, and those very meticulously they see what is the readings, especially when the monsoon is over, dam is full. That day onwards, another 6 months, this pressure is monitored. This generates so many problems because like we have cracks in our buildings, water seepage in our flat and all that thing. Same thing happens there also. Problem is big because construction is big, job is big, but at the same time, risk is also big. So many things are involved in that, and instrumentation only can help. So now, because of the mechatronics, the people who are knowing civil engineering, they are a little bit conversant with the electronics now. We are giving some systems over there which are user friendly. In the interest of the whole nation, they are maintaining the dam. So we should be thankful to them to handle all these things, what we give. So these are the instruments, 3-axis accelerometer for the dam earthquake measurement. These are very sensitive things. Digital V-notch and open channel flow measurement. This is also important thing. See, we have done something. I'm taking advantage of this particular platform, saying that we can make measurement of water which goes in cusecs. Cusecs is millions of water which is thrown by the gate of the dam. At the same time, we have made systems to measure 1 ml of water in 1 hour. 1 ml of water in 1 hour. That is also to be uniformly measured. At the same time, we can measure cusecs also. So this is the span of what we have to do. Low voltage safe lighting system. See, the dams have got inside some galleries which are called inspection galleries. Every day someone has to go there to see what is happening. That is a ritual that they have to find out what is where, any crack develop, any water seepage, anything wrong. So those galleries are totally in darkness because they are under the ground. So they go with the torches. Later on, I've seen that there were some tube lights fitted on the walls. Now all walls are totally weighty. There's water on the both sides, and there's a lot of risk of getting electrical shock. I have seen some accidents also where people have gone inside and not known for 15 days because they were inside, not come out. The people at home, they thought that they are on the job, and that fellow got an electrical shock inside and he died inside, not knowing that he was in the tunnel or that gallery. So we decided to go with a low voltage safe lighting system so that they will not have any requirement of torch to be carried, because torch doesn't give enough light. And these lights were made to work on the batteries in case of power failures, and then data loggers and other things. So actually we are very small people in industry, but we are known for such odd jobs. We did very selected jobs and difficult to handle line, because working in irrigation projects is very difficult because of various reasons. But our
Shall we
problem,
go for question answer session?
sorry,
Shall we go for question answer session? Because
yeah, I'm just
question,
this is my last skill. This thing I'm just closing it up, and that is why it's a slide for the thanks. So you can go ahead with the question answers, no problem.
yeah. So thank you very much, Mr. Sridhar
I,
Karkare,
I, I
for
believe it was interesting. Should be.
yeah. No, I think you are rather elaborated the mechatronics in a storytelling style,
Right.
which we
Right.
got engrossed, and I think we have exceeded at least 10 to 15 minutes
Yeah, I know
than
that,
the
but
normal.
it's a big subject. Sorry for that, but it must come to people's knowledge.
Yeah, so thanks a lot for this particular aspect, and we're really proud that mechatronic engineer could save a dam against the political wish, which is a great achievement. I must appreciate, because we can imagine the kind of problems and pressures you must have gone through. But
Right.
friends, mechatronics is a science which every engineer now need to practice, because you cannot say that I am only mechanical engineer or electrical engineer and I don't know that. This I learned during my Philips days when I was handling instrumentation. I cannot give a reason to my boss that why machine is stopped because it had a mechanical problem. He used to say that whatever problem may be, you are responsible. You have to find out the solution and make those mechanics to work on the areas where the problem lies. And it's a big job for the mechatronic engineer. And mechatronic engineer, rather especially instrumentation engineer, need to know all the aspects of science, because he has to finally resolve the problem and hand over the technology or machine or system to the nation. And I'm really appreciate Mr. Karkare's efforts towards that. With this little note, I would keep the floor open for question and answer. Please identify your name and ask questions.
May I pitch in?
Yeah,
Yes.
please.
Yes.
Okay, Karkare sir, first of all, very nice way of presenting the uh, very common problem of all the dams, whether small or large, it doesn't matter.
Right.
Just to while you were telling me, I did some number punching. You said 2,000 crore rupees. That was the cost. I believe it was estimated in 1990 when you conducted this work. Am I correct?
Yeah. Because
Okay.
see, these figures came to us. We didn't go for that. So that is why I remember it.
Correct. So just to elaborate on what it will cost even today, or it will have cost in some time. So
Hmm.
2,000 crore rupees invested in 1990 with 10 years of uh, duration of
Timeline.
construction. Okay.
Right.
So by the
Right.
time with the cost of capital of 15%, it will have costed 8,100 crore rupees by the time it came to 1999. Okay. And
Right.
if today and if I consider the cost of liquidity put together at the rate of 5%, which is at the RBI level, repo
Right.
rate or reverse repo rate level, it will cost 10,000 crore rupees in today's term, even if we don't construct the plant. Even if we
True.
simply budget the 2,000 crore rupees in 1990, and even if we talk about or talk of manufacturing it today itself, it will cost anywhere between 10,000 crore to 12,000 crore rupees.
Might be.
This is just the cost of finance of 2,000 crores. I
Right.
don't know what the what the
Right. Right.
costing it will how much it will cost today.
Correct. You're very right. But
So that's
that is why there was political pressure.
yes, every political party wants to have a cake of it,
Yeah,
have a piece of it.
we see it in Sardar Dam as well as so many dams in Maharashtra. We know that.
Correct.
Very
Correct.
sorry
You
to
have
say
seen that.
that, but it is so.
Correct. Correct. Correct.
So, Mr. Gaikwad, thank you for raising very good questions and information. Let me explain little more about Mr. Gaikwad. Teaching Gaikwad is an eminent industries. He has many companies there in Nagpur area, Maharashtra. He works in EV area also, electric vehicle. So, since he has joined this first session, I request him to join continuous as various sessions and grace to our program. Thank you, Tesing sir.
Thank you, sir. Thank you very much. Thanks for inviting me.
Next question, please. Please introduce yourself and ask the questions.
I think there won't be any questions because it was a story almost.
Yeah, it was a storytelling format, but really we appreciate your efforts. Those days, I think it has made your life, I can say.
Absolutely. That is why I
Uh,
said so. It must
yeah.
because
So, Tech Forum, thank you for your wonderful presentation
in fact,
today.
I also thank Tech Forum because they gave me an opportunity to, bring this
Yeah,
thing to.
because it has covered a lot of aspects, and
Exactly.
during the tenure, you have developed so many systems and instruments,
Right.
which is